Okay, let's try this again. It's the second time I'm doing this, but hey, that's all right. So we're going to do a little bit of review of factoring for polynomial equations. Here's your guys' assignment. And this is that extra video, little Rolling Stones in the back. So remember, we're always looking for a greatest common factor first. That's a step that you guys have already. After you look for a greatest common factor and you're looking at two terms, you have a couple of options. You have the difference of squares, which means that you can have a perfect square on either side, like x squared minus 25. That's a perfect square. That's a perfect square. Or you can have something a little different that looks like x to the 8th minus y to the 8th, which the perfect square of that is x to the 4th. And the perfect square of that is y to the 4th. And we can go plus, minus. So there's a couple of spots that you can see those two differences. Sum of cubes is a little different. If we go x cubed plus y cubed, that's going to look a little different because we're going to take the cube root of the first one, which is x, and we're going to take the cube root of the second one, which is y, and then we're going to take the first term and we're going to square it, which is x squared. We're going to take the second term and square it, which is, we're going to multiply the first and the second. We're going to change the sign, and then we're going to do y squared at the end. Just a pattern. There's no like memorizing or how'd you get that. It's pretty much the idea of taking the cube root of each one. So if we do the difference of cubes, x cubed minus y cubed, take the cube of the first one, x, minus cube of the second one, y, times the first one squared, change the sign, x times y, negative y squared. So those are pretty straightforward. It's a memorization thing. So if you don't memorize it, you're probably not going to get the answer right. So you're just going to have to deal with that. Don't forget quadratics. We have factoring, or we have quadratic formula. And then if we have anything with a larger power, x to the 8th, stuff like that, we're going to factor those. And then don't forget, and these are three terms. We got factored by grouping, which is going to be our four terms. So depending on what you're given, you got a bunch of different things to work with. And then if we're looking for answers, we're setting them equal to 0, and you can get a real answer, or you can get an imaginary, which has an I in it. So it just kind of depends what we're doing. So in class, we're going to deal with sum of cubes right here. In this video here, let's change this to a to the 6th minus b to the 6th. So again, this is our extra credit video. We have a possibility of perfect squares, because if I divide this by 2, I can get a cubed, and then if I divide this by 2, second term by 2, I can get b cubed. Those are perfect squares. So then I get a plus and a minus, so I have a difference of squares at the beginning. Oops, that should be a minus. Now, I have now a sum of cubes that looks kind of like that. So I take the cube root of the first one, a, the cube root of the second one. Then I'm going to take the first term, square it, change the sign, a times b plus b squared. This is the sum of cubes. Then I'm going to take the second one, because I got the difference of cubes, take the first one, cube it, cube root it, minus the cube root of b, square the first one, change the sign, a times b, take the third one and square it. So then this is the difference of cubes. So we've just used the difference of squares, and then we've done the sum of cubes and the difference of cubes. So we'll move on to the next one. This is where the video died the last time. I think I ran out of room on my computer. So let's look at this extra video example right here. So our first step is going to be greatest common factor. So I'm going to take out a 2. So I'm going to get 4x to the 4th plus 5x squared minus 6. And that's going to be equal to 0. So I have 3 terms. So I can factor that. I'm going to do my A times C multiplies to make B model. So let's see here. We're going to have x to the 4th. Actually, no, I'm going to do my factor by grouping model. So I got 4x to the 4th. And then 4 times negative 6 is negative 24. What multiplies to make negative 24 but adds to make 5? That's going to be 8x squared minus 3x squared. So let's look at this here. So still got my 2 out front. I can take out a 4x squared, and then that's going to give me x squared plus 2 is what it looks like. Okay, let's see what else I got here. Why did I get something funky there? We're gonna have to figure this one out here. So what happened here? It should work out, but maybe it doesn't. So let's just work through it here. What happened? Minus 3. This is x squared. Oh no, this is a 6. That's what happened. That's a 6. Should be a 6. Now I can take out a 3x squared. 3x, and then if I divide that, that gives a plus 2. So if we go backwards, 4 times negative 6 is going to be negative 24. What adds to make 5 and adds to make 5? That gives me positive 8 and a negative 3. I do my factor by grouping. That equals 0. So let's clean this up. 2, 4x squared minus 3, x squared plus 2 equals 0. So if I set these equals to 0, I get a little bit different answers here. I get 2 equals 0. That doesn't make sense, so that one doesn't matter. And I get 4x squared minus 3 equals 0. If I move the 3 over, I get 4x squared, and now I get x squared equals 4 over 3. And then so x is going to equal, let's kind of move it over here, plus or minus the square root of 4, which is 2 over root 3. I'm going to do this last one here. X squared plus 2 equals 0. X squared equals negative 2. X equals plus or minus 2i. So I got an imaginary solution and a real solution. So remember your factor by grouping. I almost made a mistake there. We got to have 4 times 6, and then what factors of 24 add to make 5. And then I can do my factor by grouping when it comes to these guys. So that's our extra video example there. And we have one on volume. So the ones on volume, or different answers, are going to be, so when we're dealing with volume, let's just draw our square here. Let's just here, and we know that the height is x, so we're going to put x right here. We know that the width is 3.5 more than the height, so we're just going to go x plus 3.5. And then we know that the length is 3 less than the height. Well, we know that the height is x, and it's 3 less. Okay, I could have x minus 3 over here. It doesn't matter. These can be interchangeable. Okay, so remember, this is some sort of a box. So if we draw it, we got some sort of a box. And this volume is equal to 561. So let's just set it up. What's volume? We want the volume of a box. Length times width times height equals 561. What's our length? Doesn't matter what order they go. It's x plus 3.5. And then this is going to be x. And our height is x minus 3, which is equal to 561. Just using our volume formula, taking the diagram, pieces from the diagram, and putting them here. Now, as we look at this, let me clean it up so you guys can see it a little better. This is not a pleasant equation, and I still need to find the volume. What's the height? So I still need to find x. So if we multiplied this out, we get all sorts of nasty decimals. So we know to find an x, I got to set it equal to 0. So let's move this thing over. X times x plus 3.5 times x minus 3 minus 561 equals 0. This will not be an easy equation to factor. So I can go, okay, wait a sec. If this is not easy to factor, I can use Desmos. Desmos or your calculator to graph. And graph it. And once you graph it, you're going to look for zeros that make sense. They're logical. So when you graph this thing on Desmos, what you're going to get is this. It doesn't even look like a real, it just looks like a straight line. It's going to go all the way out to 8, 1, 2, 3, 4, 5, 6, 7, 8, and it's going to draw a line right there. That's what it's going to do. So we know that this is x and this is y. So what does x equal? X equals that answer right there. And that answer is approximately 8.5. So using Desmos, we know that the width is equal to 8.5 because our zeros represent answers. All right, so watch them on homework. Watch out for these because you can put them into Desmos and you can find the answer if they're not factorable. Okay, just remember, this is not easily factored. All right. So on the back here, this is why it's good to watch the videos. On the back here, we're looking at some different ones. Number 57 is the volume. Just like we did here, length times width times height equals the total volume. Just like if it's area, it's going to be area. It's going to be length times width equals total area. So if you have an area problem, do length times width. And this one's going to end up being a quadratic probably. So remember, everything's always being set up as polynomials. These are always going to be polynomials. So if you can set it up and get your polynomials, you're going to be good. Remember on the word problems, your x-intercepts are your answers only if they make sense. All right, so that'll be it for today. It's 15 minutes. That's extra videos. Remember, if you do your extra videos and turn them in within a day and fill in the rest of this sheet, you get a little bit extra credit. All right, have a good time. We'll see you later.